Morning, everyone. I hope you're well. Today, we're going to talk about trusted and productive research environments. My name is Sushil Varma. I'm the Director of Engineering for HDA UK, and I'm incredibly pleased to have a wide range of speakers today talking about trusted and productive research environments. We have Matthew Howard from Amazon Web Services, who's the international lead for healthcare and data science at Amazon Web Services, and we'll be talking about the public cloud providers' perspective on how they provide services for research. We then have James Veers from NHS Digital, who's an experienced technologist working in the data services director at NHS Digital, and he'll be talking about the cloud data platform that they're setting up for research. We then have David Sibbald, who's the CEO of Iridia, and we'll be talking about creating a federated ecosystem for research and how they leverage Iridia's expertise to develop technologies and services for tackling Alzheimer's disease. And also they're part of the ICODA Alliance, the International COVID Data Alliance. And finally, and last but not least, we have Angela Wood, who is a reader at the University of Cambridge and is part of the British Heart Foundation Data Science Centre. And she'll be providing experiences on how she's actually using one of the trusted research environments, and a challenge to the rest of the community as to what we can improve and what works and what doesn't. So with that, I'll hand over to Matthew, who will then be able to start. Thank you.
Great, thanks, Sushil. So hopefully everyone can hear me okay. So my name is Matt Howard. As Sushil says, I head up data science for healthcare at AWS, which means in practice what I do is I work with our customers to really make cloud the solution they use for very advanced workloads, from analytics through to advanced machine learning, working extensively with the UK healthcare system as well as internationally. If we could skip on to the first slide, please. Great. So I'm going to talk about the infrastructure side, if you like, and the foundation of TREs and how we build them. And before getting into the detail of that, I thought it would be good to start with a little bit of what actually is cloud, because we sort of make these assumptions that everyone understands all these terms and are very familiar with them, and it can actually be useful to spend a little bit of time at least just discussing what we really mean. And so when we talk about cloud technologies, what we're really talking about are the use of infrastructure that's provided as a service on an as needed basis. And so moving away from traditional on-prem architectures to moving to typically web deployed services, which allow you to spin up resources very quickly and very efficiently, and critically pay for what you use. And that's a really important point. And so we at AWS, we provide, we're the pioneers actually of cloud technology, and provide a very broad set of different technologies on cloud that enable our customers to do things, really quickly. And what does that mean in practice? Well, if we go into the next slide, what it really means is that you can move away from, if you like, what we sometimes call the undifferentiated heavy lifting of running data centers, to really passing that complexity over to an organization like ours, and instead focus on the things that really are important to the science. So about being super agile in being able to spin up technologies and to innovate quickly. What is also really important, and we mustn't ignore with cloud technologies, is cost. You move away from big upfront capital expenditure to spin up data centers and servers, to moving to much more of an OpEx model. You pay for what you consume. And that's important because you can tightly couple the use of compute resources to business value. And that's a big part of using cloud resources. It's global instantaneously, which for some of our customers is very important. Organizations like Netflix, want to be global instantly. It's very quick to innovate, and it's very elastic. You don't have to build your data center to peak load. You can scale up and scale down to what you need. And that's very important as we start to think about workloads such as AI and ML, where there's requirements for certain levels of compute at certain points, but then you need to spin them down. And another part of cloud, which is important, is it isn't just storage and compute. There's a whole host of services that cloud providers give you access to, such as pre-developed databases, both relational and non-relational, to IoT technologies, to other components as well. And these are also important. So we have around 180 additional services that are part of this toolbox that you get access to when you deploy on cloud. So if we move on to the next slide, please. But what is absolutely fundamental to trusted research environments, to the use of cloud for sensitive workloads, is security and compliance. And if we think about the 5 safes that we hear about and are talked about extensively in the HDR Green Paper, there is an additional safe mentioned, which is safe computing, safe compute as part of safe settings. And that's absolutely pivotal to this. And privacy and security to enable safe compute is a key part of what we do. And what you can see on the screen here are the accreditations that we at AWS meet in order to be able to provide that safe compute. So I won't call out all of them, but you can see that we meet and exceed the requirements of the Data Security Protection Toolkit from NHS Digital. Everything we do is built in accordance with the NCSC guidance, and indeed all of our services can be run in accordance with GDPR. So what this means is you have the ability to build infrastructure that is extremely high security, extremely compliant. And if we skip on to the next slide, please, we can talk about what that sort of means in practice. And the reason that's important is because security is a shared responsibility. So as I showed in the previous slide, the responsibility of the cloud is very much with us, with the cloud provider, with Amazon Web Services. What does that mean? It means the responsibility for data center security, for infrastructure, for the applications we provide. But the responsibility for your customer data or your scientist data, or for the operating systems that you deploy, or for client-side activities, has to be with the customer, has to be with yourself. So it is very much a shared model of how we achieve the safes of how we build trusted research environments. And that's important. But it's also important to note that as a responsible cloud provider, what we also provide is an enormous set of tools and guidance and artifacts to help customers, to help scientists build secure environments that meet the requirements needed. And another thing to bear in mind at all times is, of course, that all data can be encrypted. And that's encryption at rest, encryption in motion, which means that without the decryption keys, any such data is rendered useless. So in summary then, if we think about the whole piece, what cloud provides you with is elastic, scalable, highly agile compute power, high levels of security and privacy, and the ability to very quickly provide the sort of compute power that's going to be needed for some of the workloads that we're starting to see becoming increasingly important. So moving on then, please. Let's talk about an example of a trusted research environment being deployed onto cloud. So this is something called Service Workbench. So this is an open source cloud platform that we have developed and is available on GitHub right now, and I'll provide the link shortly, and allows you to very, very quickly spin up a collaborative research environment on AWS Cloud. And it's an environment that meets the security requirements that we've got listed here. It provides components that mean you can start to actually do science very fast. And it also provides high levels of transparency. So back to those earlier value propositions, you can see the cost and the consumption that you're using of the technology. But if we move on to the next slide, the core value proposition of this, in addition to that security and privacy, is that ability to spin up quickly. So as I'm sure many of us are familiar with, the existing process of getting research environments operationalized can be quite long. As we've shown here, it can take weeks to months, from selecting and designing an IT environment through to getting the data sets onboarded. And if we just do the build quickly, please, what you'll see is the intention is we can move to a world where we really do diminish that time to science. And again, it comes back to this concept of, take advantage of the work that we've done and cloud providers have done, use technologies such as these so you don't have to redo these pieces. And that means what you can invest in is the science, you can invest in the innovation, and you're going to hear some great examples of that as we go through the session today. If we move on to the next one, please. So if we sort of take those original sort of value propositions, if you like, sort of more generally for cloud, we can directly map those to the benefits of a technology like Service Workbench. So as I said, you can reduce time to science, you can get these environments up much more quickly. you can very carefully control access to data. And this cannot be stressed enough. One of the key tenets of how we run our business, and linking again to safe computing, is around controlled access to data, controlled egress and ingress of data, and how you manage that is a key part of all this, as you would expect, which of course means you can conduct research in a very secure way and in a very trusted way. Having said that, you also do get the mechanisms to access data more internationally if that is appropriate. So for highly aggregated data, for data that is appropriate to do so, there are mechanisms to allow you to collaborate internationally. And we actually host several open data sets on AWS, which are part of the open source work that we do. A good example being the Cord-19 data set, which is a curated data set of literature related to COVID-19. Coming back to this scalability point, again, with cloud, you're not limited anymore by compute. You can scale to what you need, be that high performance compute, be that machine learning inference type chips. It's all available, and you can spin up to what you need. But you can keep an eye on cost, and that's always important. You know, I'm a former academic, very much from the grant world. Know how important it is to be able to very transparently understand what costs I'm incurring. Okay, if we could move on, please. And then just another part of cloud is, I alluded to this earlier, it isn't just storage and compute. There's a huge range of tools and services you get access to by moving onto cloud and taking advantage of basically the scale. That means you don't have to reinvent these things. So what you can see here is just a summary of the type of technologies we have on AWS. There's 180 of these now. So core services in purple, you've got your compute, storage, your databases, but you've also got some other sort of services you may be less familiar with. So the machine learning pillar, very close to my heart, where we've got pre-configured services that have been built, as well as frameworks that allow you to run deep learning models and build from scratch, if you like, through to IoT, through to DevOps, so on and so forth, as well as analytics. So the key piece here is think of them almost as Lego bricks, and you can assemble these Lego bricks however you wish to get your workloads done as part of the environments that you build. And then if we just move on, please. And lastly, just to give you a little more detail on Service Workbench, and I think Cecile has put the link on the chat as well. This actually comes pre-configured with 5 research environments. So if you're particularly interested, do please take a look. EC2 is a name for our compute, so Elastic Compute Cloud. And what we have is Linux and Windows versions available. We have our Studio. SageMaker is our machine learning environment. So what you get there is access to Jupyter Notebooks, so you can run these sort of models that you've probably been running already. Hail for genomics, for Python library, Elastic MapReduce, which is for big data compute, Hadoop, for example. All of that's pre-configured. So again, you're taking advantage of the work that has been already done to get going quickly, but this is an open source service, so you can download it and access it and spin it up. The link is there, and if you would like any further information, don't please hesitate to reach out. My email is on the screen here, and otherwise just please drop any questions into the chat and we'll either get to them in the session or we can follow up offline, and I will pass across from there.
Hi, I'm James Swears from NHS Digital. So I want to talk about what we're doing with trusted research environments as sort of the national data collection point. So if I can get the next slide. I want to start with a little bit of the history. So our data platform goes back to a world of working on SAS and Microsoft SQL, and it's evolved over a number of years. And the current platform that we're working to is a sort of modern Databricks big data environment. And we're in the process of migrating all of our existing collections onto that. Next slide. This gives a bit of an overview of how our platform sort of hangs together. We have a mixture of access mechanisms. We have a variety of sort of modern analytical tools that are available, some of them with more levels of support than others. And a whole collection of sort of governance and metadata work that surrounds that. All of this sits on top of AWS as a hosting platform as well. Next slide. The core part of our platform is a series of capabilities that actually span quite a significant area. So, you know, today we have over 100 different capabilities that have been identified as required in the platform, and some of them are highly mature and other ones aren't. But the core parts of this is that governance and security, which is sort of that orange and white bar at the bottom. are the fundamental linchpin that connects all of the pieces together. So I want to delve into two of these areas in specific. So on the next slide, in sort of the data processing and curation space, the areas that are marked with sort of those little red icons are areas that we don't have at a high maturity level today, or that don't exist, but are now on our roadmap as things that are being progressed forward. The one with the amber box is a thing that's very close to being ready, where we have the ability to look at tracking and managing each independent version of a data asset, to allow researchers to come back and rerun analysis against the same version of data that they initially ran their research on. And different elements in this are satisfied with different pieces of technology, but the idea is that regardless of how we're delivering it behind the scenes, these capabilities represent sort of the core fundamentals that our data platform needs to provide. The next slide is looking at sort of the analytical and the data access space. And there's a lot of work that we need to do here, but fundamentally it's trying to do it in a way that satisfies the 5 safes out of the green paper. So for instance, one of the challenges we have is around bringing analytical code into the environment and taking analytical code out. And the challenge in that space is making sure that we're maintaining the security envelope that surrounds it. We're also looking at how we satisfy sort of data science capabilities. And I think it's important to recognize that, classic analysis and data science analysis aren't necessarily distinct, but they have distinct requirements in terms of the types of tools that they might need, the types of and quantities of compute that they require. So on to the next slide, and you can carry forward again. So we're driving a significant portion of change, and I wanted to sort of call out a couple of the key themes that we're driving forward on our platform. So one of them is around the usability of the analysis area. It was built in a very, its early form was very crude, and we're looking at sort of rebuilding this into a modern desktop-based analytical environment that allows users to have much more local control over what their analysis environment looks like. We're also looking at changing how we govern access to the data itself. So rather than treating each individual request for data as a granular access, we're looking at a policy-based system that will allow us to actually, as Matthew was talking about, the time between the request and receiving access, part of a policy-based system is reducing that time window to as small as possible. We're also looking at metadata and how we can use modeling of metadata to actually drive automation within the platform, both at the ingestion and the curation areas, but also how a more robust metadata model supports the research community in how they actually perform their analysis. Next slide. We're also looking at how we bring data into the platform. So rather than having to ingest each new data collection atomically at a time, we're looking at can we drive that out of a configuration and an introspection basis, so that actually we can bring new data into the platform very quickly and at scale. And part of the challenge there is we have 200 plus data collections that need to come onto this platform, and it's how do we deliver that quickly. And the final one is just about allowing our data managers and data scientists internally to have independence on the platform, so that they're able to operate in their own way with the right guardrails and controls in place, but they're able to operate independently of the platform teams. On to the next slide. I wanted to address how those internal themes sort of fit onto the TRE service that we offer. So one of them is, improving that analytical environment is about providing more collaborative features. It's about providing an improved user experience with more tooling, and additional tooling allows more flexibility for the researchers. We're looking at, as I mentioned, about automating the provision of data. And that extends not just to data collections that we hold, but also being able to allow research communities to bring their own data sets in and be able to automatically grant access to it. which also touches on the data pipelining. In order to link data, we have to have processed it the right way. And being able to do that automatically and at scale allows us to let research communities not only bring their own data, but have it linkable to ours. The data science environment has long been on our roadmap. It's been a challenge for us, but it's a challenge that we're now actually starting to address. And the next slide. And that's sort of it for me. I guess I'm under time, but I think that goes to Dave next. David, yep.
Great, thank you. So good morning, folks. So I'd like to take the next 10 minutes or so just to talk about some of the dynamics, some of the key requirements for building and sort of running global research networks, or if you like, creating an ecosystem for research, just by picking up on a few of the headline phrases on this slide. So those research networks are generally focused on a single disease and recognize the reality that good and useful data never resides in just a few repositories, but lives in many places. It's in academia, healthcare, industry. It's global, and what's actually important is the ability to understand what data is available, understand the rules for access to that data, and then create an environment where multiple inflows of data can be brought together and worked with. And so the example I'm going to use to bring this a little bit to life is the Alzheimer's Disease Data Initiative, or ADDI. So ADDI was launched by Bill Gates 2 weeks ago, following a pretty extensive 2-year pilot program. You can read more about that on his Gates Notes blog. The initiative is funded and supported by a global group of philanthropic, patient advocacy, public and private partners who are really intent on accelerating the discovery and development of sort of disease-modifying therapies for Alzheimer's. So networks like ADDI have got a common requirement to enable a large number of, as we're saying here, many-to-many interactions. So between data contributors on the one hand, data users on the other, and to make those interactions happen with a very high level of trust and governance. And within that, there's two key requirements. The first is, how do you discover and access data? And then the second is how you actually work with that data. And so we know that data access and data sharing is the longest lead time item when it comes to making complex collaborations work. And we all need to work to improve that lead time. So to help this, and along with the ADDI community, we've built an approach and a framework to provide data contributors with choice as to how they participate in the network. And I'll talk more about that in a minute. On working with data, it's clear that the skill sets and requirements from the user community are very diverse, and that there's a real requirement for capacity building. And I'll talk more about that in a minute as well. But first to ADDI, if we can just switch to the next slide, Izzy. So Alzheimer's has a scary kind of demographic timeline associated with it. And it's also got a disappointing track record in terms of therapy interventions. So Bill Gates called this out in late 2017 and established the Alzheimer's Disease Data Initiative, which ran a number of extensive pilots that really follow the workflow that's indicated in that diagram in the bottom left-hand corner. 2 weeks ago, launched ADDI as an independent medical research organization and launched the AD Workbench as the platform approach to discover and work with Alzheimer's data. And there's a nice kind of 1-minute video to play. Izzy, if you could just turn that on.
This is a dot, a pixel, a single data point. Alone, it means very little. But when we add to it and create connections, the picture becomes clear. This is the Alzheimer's Disease Workbench, a secure cloud-based platform where collaboration will drive the development of new innovative therapies and could even lead to a cure for Alzheimer's disease and related dementias. Using the AD Workbench, the global community of Alzheimer's researchers can request data, work with it, and share their findings. But this is just the beginning. We will continue to grow, adding datasets, tools, and features that expand our collective knowledge and accelerate discoveries. Together, we can connect the dots. Together, we can find answers for the more than 40 million living with this disease.
So ADDI is a very ambitious and a very necessary global program that requires us to enable both productive sharing of data and an environment that encourages innovation and choice from a data science and an analysis perspective. And so I want to just talk about those 2 points briefly in sort of remaining time. So for data contributors, our approach here is to ask data controllers to self-select the level at which they want to join the network. And there's currently 3 levels, of which federation is one. And by federation, I mean an analysis request from the AD Workbench is shipped to a remote repository, run locally, with the results returned back up to the Workbench and no record level data moving. It's the most complex of the 3 data access levels, and it may or may not be the best approach, but it is an option for data contributors to consider, and one that's highlighted as preferable, at least in the UK, and is called out in the HDR UK Green Paper. So specifically for this approach, we're providing an open source, open specification, and we hope eventually an open standard for data contributors to implement locally and join one or more data sharing networks. We're packaging existing standards where they're applicable and where they fit. And so I'd encourage you to take a look at the URLs on the slide set and get in touch if you're interested in learning a little bit more, or if you're interested in contributing or participating in the program. And next slide, Izzy. And for switching to the working with data piece, for researchers or for data users, there's a couple of things I'd call out on this slide. So our approach acknowledges the diversity of the user community and the very long tail of use cases and skill sets that exist. So our experience over the last 10 years is that the wider community of healthcare, clinical and scientific users are not particularly well served by existing HPC services and can find the use of native cloud services to be a bit of a challenge. So user experience and capacity building are really important aspects of what we're doing and what we've done with the Workbench. If you kind of switch towards the sort of right-hand side of the slide, if you take a look at the general workflow for analysis, the query, visualize, test, model, learn, the Workbench provides on-demand access to secure audited workspaces for people, for data, for code to come together and collaborate. Research groups can specify the level of compute resource for their project, have that automatically provisioned, and call out the data table analytics. We've developed a data frame model there, really for sort of clinical and healthcare domain experts to be able to visualize the data, run common biomedical stats in a point and click fashion. So sort of time to value is pretty rapid, but simultaneously generate the code from that analysis to develop further in a dedicated R development environment. So we're trying to help make that transition to working more programmatically, to sort of building capacity within the wider community. Users can build interactive apps quickly, publish their work to the wider scientific community. And add-on components range from containerizing existing apps that the community thinks are useful, to connecting to a range of advanced PaaS services on the cloud, abstracting some of the complexity from a user's perspective. So summary, and I realize just about out of time, our focus here is to build an ecosystem where contributions of data, domain expertise, models, apps can be accommodated on a project by project basis. This runs on Azure, which allows us to offer data sovereignty within individual countries, and a self-selection approach for data contributors, which allows them to understand the use and application of their data into individual programs. So I'll leave it there. Thank you.
Hi, good morning. Thank you for the invitation to be part of this session. I've been asked to speak about my experience using the new trusted research environment developed by NHS Digital that James alluded to, that now hosts the major healthcare datasets in England. So I'm a user, a bit of a background about me, so you can place me in that diverse distribution of the user community that David just described. I've been working on electronic health records for the past 18 years. I started using the Scottish morbidity records to understand the risk of pregnancy and birth outcomes. I've also analysed data from major primary care and hospital data resources in England to understand cardiovascular disease. And alongside this, I've analysed a lot of data from multi-cohort consortiums. And for all these analyses, I've always had to work in a computing environment which ensures that the data remains secure, but also has the capacity to allow analysis at large scale. My contribution really has been to leverage the information that's available in these data sets, applying what I would call advanced but very transparent statistical methods to reduce or eliminate potential biases to produce reliable results. Can we go on to the next slide? So in May this year, I was enthusiastic about joining the challenge to analyse the electronic health records at scale across the nation. So I became involved in the endeavour led by Professor Cathy Sudlow as the director of the British Heart Foundation Data Science Centre on the CBD COVID UK project. The aim of the project is to understand the relationship between COVID and cardiovascular disease using these nationally collated healthcare data sets across the UK. Can you move to the next slide? And so from that, the NHS Digital TRE for England was established. And to consolidate your understanding, this is the first time the major healthcare data sets across England have been collated and linked across for the full English population for research. As James described, NHS Digital have collated and they've linked the data from patients with hospital admissions, death registrations, primary care records, and community prescribing data with COVID test data. And those data sets are in black text on this slide. And there are ongoing efforts to further link these patients with their records from intensive care data sets and also cardiovascular specialist records. So these data have been pulled together and linked by NHS Digital and are now stored in what we call the NHS Digital TRE for England. And there are now around 10 to 15 approved researchers who can access this TRE and start to perform approved analysis. Can we go to the next slide? So although my focus today is very much on the English TRE, the work is in parallel to existing and emerging efforts to establish environments in Scotland, Wales, and Northern Ireland, with a kind of a scientific goal to perform similar analysis or using common analytical protocols in each of the environments before pooling the results together. Can you go to the next slide? So this slide serves to kind of describe my journey so far in the NHS Digital TRE, and these are just the highlights. So as I said, there are a number of researchers who are within the environment. There are around 10 to 15 of us, and we were interviewed in May by NHS Digital about our past experiences of how we've worked in secure environments for data analysis to help inform and shape the design and functionalities of the new platform. And I think that was a really useful experience, both for us and for them. Once the platform had been designed and we were able to access the TRE, we spent quite a lot of time actually structuring how we were going to work together across the multi-institutes. For example, when it was first established, researchers in Bristol and Cambridge and UCL, we all had our different spaces, almost a different platform. And we soon realized that we needed to be able to see what each other was doing. So these separate working platforms have been folded, and there's a single platform, and there's collaborative spaces within that where we can now view each other's code, output, and data resources within that we're building. We've obviously spent a lot of time checking the data and cleaning the data, and that remains ongoing. And we've also been writing and refining analysis plans. Now, scientifically, these are crucial, so we all know what we're doing, but actually from a, an analytical point of view and within the TRE, it's really important because we now know how we're going to prepare the data sets for the plan analysis and prepare these reference code lists, define the different variables that we're interested in. The scientific proposals now also have an approvals process. This includes, basically scientists, anyone can put in a proposal that's under the realm of the scientific goal of CVD COVID UK at the moment. And those scientific proposals are reviewed, as are the data sources that are required by a scientific and lay member committee. And then we've been spending our time on doing descriptive analysis of the available resources and the preliminary analysis of the approved scientific proposals. Can you go to the next slide, please? Thank you. So I want to describe a little of what the environment looks like when, as a user, we log in. So suppose the little figure in there is me. And to log in, I simply use a web browser, and it's a two-factor authentication. And I have two options when I log in. One is to go to the Databricks platform, and that holds the databases and also has Python and SQL programming tools. Or I can go to RStudio. Now, typically what I do is I go to both, and I have them both in different browsers. Now, I can still access the databases through RStudio through a link that it has with Databricks. But what we've been finding is that this link is very weak and it's got limited memory. So I can't read in the raw databases directly into RStudio at the moment. I first of all have to reduce that within Databricks using Python or SQL to do that before I can access them for analysis into RStudio. Another important feature is that as a user, I cannot input anything into the environment, such as extra data, reference code lists, or maybe an analysis program that I want to repurpose. However, what I can do is I can copy and paste things into the environment. So as long as it's it's not pages and pages long that I want to copy and paste, then that suffices. In a similar way, neither can I output anything from the environment, including results and figures, without it first having to be approved by the NHS digital team, which has a 48-hour turnaround. Can we go to the next slide? So what are the key ingredients that are making this project work so far? Well, obviously it depends on the availability and linkability of the multiple data resources that are now in the environment. But crucially, it also depends on the multidisciplinary team that's collaborating and working together. And so far, I've shown the people who are quite heavily involved on this slide, but none of us are directly funded to do this work. A lot of it has been through goodwill and our interest in working in this environment. Of course, the project also depends on ensuring that the data remains private and secure, and as scientists that we are trustworthy in analysing that data. And of course, that all of our partnerships, especially between the academics and NHS Digital, remains transparent and open. And I put there that, as we've talked about previously, that we are committed to the 5 safes. Can we go to the next slide, please? So I thought you might want to know what's working well and what's not working well. So what's going really well is the fact that as users, we're working really in partnership with NHS Digital very much since the start, and we continue to meet on a regular basis. Also, the cross-institution academic researchers collaborating and working together is going really well. And again, is this just building up a research team with different skills, appreciating each other's gifts and training. We noticed or realized quite early on, and I'm sure we know this anyway, that our success really depends on having dedicated data curators or managers. And we've recently employed 2 data curators who've come from NHS Digital, actually, who really understand the data and supporting us as we manage the data sets and get them ready for analysis. I think another important key feature that works well is that as analysts and users, we have hands-on access to the data. I almost want to call it that we are able to have a relationship with the data, we understand it, and we can view it informally before we need to do our formal analysis. Importantly, we've learned from other TREs, especially SAIL, through our collaborator Ashley, who's really helped us taking his learnings and bringing them into the TRE. NHS Digital have also provided and formulating manuals and guides for different stages of analysts using the environment. And quite recently, we've brought in some PhD students to do some training projects in the environment, and that also seems to be going well, that kind of process of bringing in new people working alongside others. Can we go to the next slide? Because maybe this is what you were waiting for. What's kind of held us back and what's not gone so well? Well, there have been delays in data sets availability and linkability. We started this in May. I'm sure it started earlier than that, actually. But the hospital admission data, we really only had that fully linked at the end of last week. I kind of alluded to that there is this lack of user control with regards to inputting and outputting from the environment. And users at the moment really need to know SQL or Python skills to really progress anywhere due to this limiting feature within the RStudio platform. There's some technology must-haves that aren't quite there yet, but actually we are working on this, and this is to get GitHub or GitLab for version control and collaborative work within the environment. I've alluded to this more memory on the link between Databricks and RStudio. There are no GPUs or acceleration chips yet, and actually, as an analyst, I don't really understand what the computing capacity is of the environment. Things which still need to be determined, the data is updated on a monthly process. We don't know how successful that will be or how we'll be able to work with version controls of the data. It's still to be determined how we will access data in Wales, Scotland and Northern Ireland and pool the results. And as yet, I'm not sure how the environment will scale up to more analysts and high performance computing requirements. And I've just got one final slide, which is really just forward thinking. How can we look forward and increase productivity in this environment? I do think we need dedicated funded researchers and not rely on goodwill. You know, the way that the environment is working at the moment is that we can work on COVID and cardiovascular related research. It needs to be extended to be more broad. Extend functionality so it's accessible to broader skill sets, so not dependent on Python and SQL, and establishing these overarching approaches across the 4 TREs. I know I've gone a couple of minutes over time, so apologies for that. I'll end there. Thank you.
Thank you, Angela. Thank you, everyone. So Matthew, David, and James. I've seen a large amount of questions being answered in the chat by David as well. So thank you, David. So there's the other David, David Seymour, answering the chat. So I just want to, with the limited time we have, I just want to pick up a few of the questions that are still open. So the first question, I think, for all of you, and anybody can raise their hands and answer, is what do you think as a community we need to do more or less of to involve the patient public in shaping the direction of travel? We've heard from the trusted research environment providers, we've heard from researchers, but one group we need to engage with and improve on is the public and patients. So what are your thoughts on that?
I think the challenge will be that we need to make sure that the public and patients are aware that their health data can form part of this. I know within the NHS, we have a patient opt-out service, so people are able to elect to have their data removed out of the set that's available for these types of purposes. And I think as a collective group, we probably need to make sure that actually patients are aware that that option exists and how to exercise it. And we need to make sure that it's applied universally across all the TREs.
Anybody else? David?
Sheila, I mean, just a general comment. I mean, I think survey after survey shows there's enormous public goodwill in terms of contribution of patient data into sort of range of research programs. So I think that's there. I think what's missing is there is no feedback loop on that, or there are very poor feedback loops. So if your samples are part of a study that you've given, are they being used? Where are they being used? So the consent is granted. But that feedback loop in terms of how your data set is getting used is kind of missing. Patient advocacy groups, charities are picking up on some of that stuff. That's probably the best place for that to be surfaced. But there's a lot of work to do that. So the TREs have got to push the usage of data sets within various scientific programs back into that community to sort of close that loop.
Thanks, David. Thanks, James. Oh, James?
Yeah, just to touch on your point around sort of goodwill there, David. You know, the patient opt-out service within England, at least, I believe it's only somewhere around 1.6 million people on that list out of the 60 odd million people that live in the country. So it is a very small uptake of people that choose to opt out of health research.
Thanks, James. And yeah, and it also touches on the one of the questions on how you recruit consumers and service user representatives, either through ourselves or through an organization representing patients. Now, HDA UK doesn't have a hard and fast policy on this, and we would happily engage directly with consumers and with organizations. Now, again, our bandwidth will be limited, so preferably we go via the organizations because it'll be easier for us to collate all of that information and provide that to trusted research environments. But feel free to reach out to us individually as well if there are concerns, or thoughts and comments, and we'll try and address them as well. One of the themes that I think has been coming out through the chat, and this was not a direct question, but one of the themes was around how we can align the trusted research environments and thereby increasing the capacity and capability of researchers to work in these modern environments. We're all providing modern stacks of research capability. How do we ramp up researchers into using these spaces? If you would ask me, I would be happily working on my laptop. But one of the things around working with health data is working in these research environments. So what are your thoughts on ramping up researchers to use these modern architectures? Yes, Dave.
Sushil, so I mean, I think this is a sort of key area, and there's not necessarily an easy answer for it. But my kind of view on this is that the sort of very high end users, sort of professional data scientists, PhD, biostats folks, are very well served programmatically by HPC infrastructures that have been procured over a long period of time, and that's the 10%. The 90% of people who've got great domain expertise from a clinical and a scientific and a healthcare perspective are basically being ignored, right? So there's just an assumption that that community can jump into this advanced programmatic environment just like that. And that it's just, so that 90% is kind of being ignored. And so that user experience, that capacity building piece is something that we see day in, day out. And a big part of our focus is to provide, in essence, a web experience that really helps that community just do their work, because they have tremendous expertise within their domain, but they're not, as you would expect, professional data scientists. So it needs to be a journey. And that's something that we're very, very focused on.
Thanks, David. James?
Part of I agree with David's sentiments that, you know, the programmer-centric view of it is easy to satisfy. It's the piece that's well understood. I think it's you know, when you end up with people that aren't comfortable writing Python code or R code, that actually there is a significant gap there. What we're looking at is a series of sort of profiling tools and exploration tools, and building conformed models that are able to answer sort of a wide range of standard questions that people might ask, so that actually we can present dashboards in a graphical interface that allows the clinical level of researcher to actually go and have an overview of the data without having to sit there and write a Python notebook to actually do that for them. We're still looking at how we support the technical end better, and as Angela pointed out, there are issues that we're aware of and that we're working on, and so I think it's important to give sort of that analytical oversight of what is the shape and the form of the data that you're actually being presented with, because that can go a long way, at least in my view, to helping the researchers understand if the data they actually have access to can even answer the question they're trying to ask.
Yeah. Thanks, James. I'm just aware that we're just over time. We've answered some of the questions. We'll follow up with you if we haven't answered them. So thank you again for all of the panelists for speaking today. Thank you for attending. The next session will be starting in about 5 to 10 minutes. So that's the Innovation Gateway demo. So I'll look forward to seeing you all there. Thank you again for participating and the questions, and we'll follow the conversation either on Twitter or through the chat window in Zoom and in the Q&A in the next sessions. Thank you again, and I'll hand back to Lizzie.